Hello, everybody, and welcome to this week's Hubble Hangout. My name is Tony Darnell. I work at the Space Telescope Science Institute, and this week we've got another great hangout plan for you. If you are interested in Hubble data or in getting some yourself, then this is the hangout for you, because we're going to be talking about a new and revamped Hubble source catalog that you will be able to peruse and query and get Hubble data yourself. So that's in just a moment. I'll introduce our guests that will help us understand how to go about getting this stuff. But in the meantime, before we get started, a couple announcements. Hubble Mania still going on. The link is down in the description box. Go vote. Vote early and vote often. Actually, you can only vote once. But the latest round 3, has started yesterday. And my favorite image, the Hubble Deep Field, died long ago. But now there's still a few that are still out there. The Pillars of Creation is still there.
That makes me so sad. You have no idea how sad.
Believe me, I really pushed for it too.
Yeah.
And but you know, the Sombrero Galaxy is still alive, which is great.
Yay! That's yes, that's the observation. I rule.
That's the one I'm rooting for now. So we'll see how it goes. Also, the voting is still going on. The crowdsourced voting is still going on for the Ode to Hubble video contest. They had a lot of great submissions. So please go. The link to that is also in the description box. Go to their website, and you need a Facebook account because they base it on the number of likes. But you can like as many videos as you actually do like. So please go and vote for that and participate there. We just got back from South by Southwest, or at least many people are getting back from South by Southwest, where they had a big exhibit and things going on at the Interactive, as well as the Gaming Expo. So if you were in Austin, I hope you had a chance to go down there and check that out. So before we get started with today's hangout, let Scott know. let Scott tell you how to leave us questions and comments.
Let me know. I don't know what I'm doing. Let me know, Tony. So, for those of you who are newly joining us, there are many, many different ways for you to get in touch with us. The easiest and most effective way is to use the Q&A app. So you're watching us over on YouTube right now, or embedded somewhere on our website with the YouTube. You'll be on the very bottom left. It says that we're engaging with you. You're allowed to ask us questions live on air, so it will populate to our right, and we'll be able to click them and answer them live. So if you have questions for any of us or any comments that you'd like to make about today's topic, please use the Q&A app, and we'll be able to not only select them, but it will put a timestamp to whenever we answer your question. Another thing as well is we are over on Facebook. So, excuse me, well, we are on Facebook, but I'll be checking the Hubble Hangout hashtag over on Twitter. So if you haven't already, follow us on Twitter at Hubble Telescope, and I'll be monitoring that hashtag too and replying back. And we'd love to see what your favorite images have come out of the Legacy Archive as well, if you've done some in the past, like Judy Schmidt. And I know you have.
Know who you are, Judy.
I know you have, Judy. I know you're probably watching. So please share with us your favorite images that have come out of the archive and what you've learned from previous sessions with the Legacy Archive and what you're learning today.
And did you tell them about YouTube? You can comment on YouTube as well?
No, I guess.
Yeah.
If you want to comment on YouTube,
we're also monitoring those as well.
We will monitor them. I am also moderating them too. So please keep those
it's come to that,
comments.
Folks. It's come to that. We have to monitor.
It's come to that, but it's YouTube, so that's okay.
Yeah, the wild west of the internet. You know, it's funny. I had a lot of fun last week on Twitter looking at the Hubble Hangout hashtag tweets, where there was a little thing going on where a lot of people were coming up with new names. In addition to Hubblers, we had one of my favorites was Hubbies, which then led to Telehubbies, which
Thank you, Heather.
And there but my all-time favorite was the one in Spanish, Hublandos. So
I do like
silent in that because it's Spanish. So hola, Ublandos.
Ublandos. I like it.
Ublandos.
But we can thank Telehubbies to Heather, who's from Johnson Space Flight Center, and thank you, Heather, so much for that. You were amazing.
Telehubbies was hilarious. Yeah. So if you've got any more, keep them coming, because that was really. We should have a contest. We talked about that last week. Okay, so the Hubble source catalog. Carol, I got to introduce you.
How
Hi,
could you
Carol.
do it?
You're muted. That's why. When you mute, you just disappear to me. So,
Oh,
hi, Carol. Dr. Carol
I
Christian.
am dead to him.
You will never be dead to me,
Talk to
Carol.
the head.
Thank
Talk
you,
to the
Scott.
You're always
You are
screaming
dead
in
to
my
me.
head, no matter what.
Thanks.
I disown you. Dr.
Thank-
Carol Christian is the Hubble Outreach Project Scientist. She joins us every week. Hi, Carol.
Hi, your funding has just been cut.
Ooh, note to self. Be super nice to Carol. Okay. So the Hubble Source Catalog it's been around for a long time, and it keeps getting updated. And as you all know, Hubble is celebrating its 25th year collecting data, and eventually everything Hubble looks like makes its way into this archive. And if you have ever been wondered how to get at this and how to use this data, we'll show you that today. And it's gotten a nice revamping by the Hubble Source Catalog team. So joining me is our various members of the group. It's a bigger team than here, but these are the ones that are going to show us how to use it. We have Dr. Brad Whitmore. He's an astronomer here at the Space Telescope Science Institute. Also, Steve Lubo. He's also an astronomer. And I see Rick has joined. Hi, Rick. Rick White, also a member of the Hubble Source Catalog team, and also from a remote location high in the Arctic. I don't know where he really is, but is Tom Donaldson. He's one of the programmers that I have a feeling knows this thing inside and out more than.
Or Fred. I hear he also goes by Fred.
That's true. He does. I think that's his alter ego there. So anyway, so let's go ahead and get started. Brad, why don't you give us first of all an overview of the catalog itself and what it is you're going to be showing us.
Okay, well, I think as most of our users probably know, Hubble's been in orbit now 25 years, and so we've got a lot of observations. We've got over 1 million observations, and for an astronomer, that poses a problem. I mean, it's hard to find sometimes exactly what observations you need. In many cases, there's so many observations, it takes a long time to work on. And so that's what the Hubble Source Catalog is all designed for. Now, at the basis of that is actually the Hubble Legacy Archive, which is where we'll start right here. So if you just do a Google search on the Hubble Legacy Archive, why don't you go ahead and switch screens there. There we go. Here we go. It's the second one. Welcome to Hubble Legacy Archive.
Wait a minute. What's the first one? Human leak? Oh, okay.
Okay, there you go.
Well,
tell me
HLA.
all about this, Tony. Yeah.
So, to be fair, that's HLA, which could mean anything. But
Yes, I
Hubble
know.
Legacy Archive.
But it does show up quite a bit.
Yeah.
So the Hubble Legacy Archive has been out since, I guess, 2008, and the Hubble Source Catalog is kind of a new compilation of all the source lists that get made. And so I'll kind of show you a little bit of it here, and then Steve will go in a little more detail. Let's skip the instructions, go right into the site.
That's
we don't want to read the manual.
Because that's what astronomers do. We don't. They spend all this time writing the instructions, and it's like, forget it. We're just going to go straight in there. Yeah,
change
really.
log. Who needs a change log? Let's go.
Exactly.
Okay, and so I'm going to take this from an astronomer's standpoint, which is I've got some object I'm interested in. So I'm going to go to Small Magellanic Clouds, SMC.
Well, you're into those acronyms.
Okay, Small Magellanic Clouds.
Okay.
So it's a dwarf galaxy in the southern hemisphere. It's quite a bit closer than even the Andromeda Galaxy, but since it's a dwarf, it's not as popular. Anyway, here it is, and you can see, here's the problem. We have 11,000 observations with Hubble of the Small Magellanic Clouds.
Woohoo!
Is that it?
This is going to take a while.
I expected more.
Oh, yeah? Okay. Sorry. Okay, so here we are. We can go to footprints. With the spinning ball, which hopefully is going to go away in a moment or two. But anyway, on the right there, what you're seeing is a picture of the Small Magellanic Clouds, and all these little dots here are individual footprints. And here's kind of a compilation. With the advanced camera for surveys, there's been 2,500. Wide Field Planetary Camera 2, over 2,000. The newest camera, Wide Field Camera 3, 700, etc. So if I was going to work on this myself, I would be downloading data from this for days until it essentially got it all, and then I'd have to figure out which data is actually useful for me.
Could you explain to me what what you mean by footprint. So if someone's logging on this for the first time, they might not understand what you mean by footprint. What exactly is that corresponding to?
Right. So okay, that's the field of view. For example, the advanced camera for surveys, when it takes an image and that little footprint from it, that's the part of the sky that it sees. So it's a very small, what we call kind of pencil beam of the sky. So that's probably a lot of people don't realize that the images from Hubble are a very small part. I don't know how many it would be. Maybe someone can calculate for me. But if someone wanted to look at the moon, it would be hundreds across. It would take you forever. So we only do very small parts. Okay, so there are all the observations. Let's go ahead and limit it a little bit. Instead of doing all the instruments, let's just go ahead and look at the wide field camera 3 observations. So now we're down to 700. And so let's look at a few kind of thumbnails.
You could have selected that also in that map that you had, where the list,
yes,
right?
yes.
You can select just one. And I was also going to remark, which I think people figured out, but each one, the reason that the names of the instruments are colored is because the color, of course, is reflected in the footprint color. So you can tell which ones are ACS, which ones are COS, etc.
Right, okay, good, thank you. And so each of these, for example, are in a different filter or different color. This is kind of in the red part of the spectrum. But we're going to look at the nice color image. So here we've added 3 different colors, kind of a blue, a green, and a red all together. And we're going to look at the interactive display. Just a very quick note, not to slow down here. These color images are made automatically. It's not like a person goes ahead and kind of mixes them. This is done in an automatic algorithm. So here is a nice part of the sky, a lot of really bright blue stars, some red ones.
That one doesn't show
up.
Is it a pop-up?
It does, yeah. They just have
Okay, yeah, what do I do with pop-ups? Sorry.
Oh, you're sharing. Oh, so you're
back down.
You have to
It's like
share the
whack-a-mole.
screen. I can do it. Here, close this.
There you go.
Sorry. I've got to wait.
Okay, as he's kind of setting it up, I'll kind of tell you a little bit more what it's going to be. So it's kind of a big picture of that image, and the first thing we'll do is look at what we call a source list. It's just a catalog, and we make these for all the images, all the tens of thousands of images. We make a catalog here using either DAO photo or source extractor. So here we are. Here's our catalog of all the objects. And now the next problem is I have to add, tens or hundreds of these together to make the master list, and that's the Hubble source catalog. So in this particular case, let's go ahead and require 30 observations before we include it in my catalog.
And the reason for that, Brad, is so that we could have enough signal to really be able to get good photometry from it, or what's the reason for that?
Yeah, partly. Let me. If you pick too small a number, you may get a lot of artifacts like cosmic rays, etc. And so essentially, you're kind of filtering out the artifacts. And I know 30 is a pretty good number here, as we'll see. Some of these have hundreds of observations. Now,
okay, and artifacts are these things that come that these images aren't pretty right off the bat. They get hit by cosmic rays, like you were saying. There's also other things like bad pixels or whatever that could also be in there and affect the quality of the image. And so by adding more of these together, you not only increase your signal of the whatever it is you're looking at, but you also remove these artifacts. Correct?
Right. Exactly. Yep.
Okay.
Now,
I don't mean to. Just one more quick thing. I want to clarify what a source is. A source is either something like a galaxy or a star or something in the image is considered a source, and these are all found automatically by the software that Brad pointed out, DAO photo or source extractor.
Yep, exactly. Yep.
Okay. Go ahead.
So another, if you will, kind of artifact here is that they don't always line up real well. And so, for example, you look at these and say, wait, those aren't lined up with anything. And
yeah, empty circles.
I challenge you to look, and I'll give you another like 10 seconds. Where are these 2 objects? All right, they're over here. Okay, and that belongs over here. Everything needs to be shifted over to the right about that far and down, and then all these will line up, and that's exactly what the Hubble Source Catalog does. And Steve will be talking about aligning and matching the objects. And so here we're going to apply the astrometric shift, and that comes out of his algorithm. And now, do I need another screen, Rick?
No.
Oh,
it's
there, it
showing
just took a while.
Yeah.
Okay,
Yeah.
good. Anyway, so now we're all lined up. Okay, and so that's the Hubble Source Catalog. You can get information by looking at one thing at a time, or in a minute or two, we'll start looking at what's called the Discovery Portal, which allows you to kind of look at all the data at once and do some work on it. But just a quick thing, you can see 48 different observations went into this. So imagine how long it would have taken you to download all that data, combine it, make the source extractor catalogs, figure out which objects are right, get all the matching right, and then finally you'd be ready to do science months or even years later. If I could go to image 2 now.
Or if you have a slave graduate student.
Yes, which you have to pay.
Can I get you to comment on these other catalogs here? I'm seeing something from Sloan and 2Mass and GS.
Right.
What's GSC2? I don't know what that is.
Guide
What
Star
are those?
Catalog, Guide Star Catalog
Guide
2.
Star Catalog.
Right.
Oh, okay.
And so we'll probably talk about this a little later, Tom. The Virtual Observatory tries to make all the information from all the observatories, and so Sloan, this is the SDSS is a Sloan Digital Sky Survey. 2Mass, I'm not sure what the acronym stands for.
Micronal Sky Survey.
Okay, etc. Galix is a UV telescope,
first?
etc.
Yeah.
Okay, well, since Rick's part of FIRST, tell him what FIRST is.
First is faint images of the radio sky at 20 centimeters. It's a radio sky survey from the That's my data. So.
I love that name. That's awesome.
Okay.
So and Scott's got your image up, but before you go to it, this source extractor 18,592 in parentheses. That's how many objects source extractor found.
Yep,
in this image?
On that particular image. And,
Okay.
and we'll try DAO photo. DAO photo looks more for point sources, and we got 20,000 of those.
Wow. Okay.
So
All right, go
let's
ahead.
go to, yeah,
You
so
might
let's go,
zoom way out to show.
well, let's move ahead.
Okay.
Okay. Yeah, so if I could get image 2 there. Okay.
He's got it up.
Okay. So this is just to finish the thought. I mean, this shows the same footprint in the center and all the images. And what the astronomer really wants is the figure in the upper right. That's a plot of all the data. So for ACS, we have 385,000 data points, and this is what's called a color magnitude diagram, where along the x-axis is V minus I. So on the left is blue, and on the right is red.
Whoa. I'm seeing a screenshot of a bunch of what we just saw. That's what I'm seeing, unless I messed up. Oh, sorry, I had to refresh.
Okay. Okay. So
Scott's
anyway,
screen.
That's a color magnitude diagram. For the people that know a little astronomy, they'll recognize that, oh, that's the main sequence on the left, and that's the red sequence of giants on the right. And the main point, if you read the caption, is instead of taking months to put this together, you can do this in less than 2 minutes.
Wow. That cuts down your time a little bit.
Yep. Okay. Let's see. Any quick questions that we want to answer now, or should we go on to Steve's part?
I'm not seeing any right now, but then, oh wait, let's see. Now here's a comment from Judy is like, I've been exposed. That's what she says. Steph Dust Bunny is also commenting, hi Hubblers, that's his fave. May just be me, but I couldn't find a link to tonight's event on Hubble Google Plus page. Yes, we had some issues with that, but we're getting that fixed. So that's what I have so far, so you can go ahead and continue.
Okay, Steve?
Okay. So I will discuss a little about the development of the catalog. The project began in, actually the idea began in 2008 with collaboration between Johns Hopkins and Space Telescope, Tomasz Budabari at Johns Hopkins, and I at Space Telescope got together to write a NASA proposal to develop a catalog that would provide this capability that Brad just showed. And fortunately, the proposal was accepted. We began work in 2009, and by the end of 2011, it was a 3-year grant. So the first 2 years, we tried lots of ideas, which didn't work. And in 2012, we decided to simplify our approach. We found something that did work, and in the last year, we were able to generate a beta version of the catalog, And at that time, the user interface for it was based on forms, not sophisticated graphical interface like the Discovery portal that Tom Donaldson will show you, but it allowed people to search for data for sources in the source catalog based on various attributes such as position or filter or various things. And at the end of our grant period in 2012, we were very fortunate that the Institute here decided to fund the project, continue it, and expand its membership. So the Hubble mission and the MAST archive have been supporting the project, and we've made considerable progress in the past 3 years since the end of the grant period in making it more accurate, more user-friendly, more user interfaces for it, and so on. So I'll now tell you a little bit about how the catalog is constructed and some of its properties. So if Scott, you could bring up the first slide from my presentation.
Yep. Mm-hmm.
Okay, he's got it up.
Okay, so as Brad mentioned, there are these source lists. So and it's based on the Hubble Legacy Archive. So that was our starting point for the Hubble source catalog. So what the source lists really look like are tables. Okay, so it just, for each source there's a position, there are properties of the source like its brightness, its size, and so on. And these tables, then there's one set of
these tables are tables in a database, right? These are databases.
Yes, that's an important point. Well, they start as files. Okay, they're files on disks that are the output from the source extractor or DAFO. We rely on source extractor for this.
Yeah, that's pretty much everyone does. It's a big piece of software that does it automatically, because as we pointed out, to do it manually would be untenable, I think.
Right, exactly. So they are then imported into a database, and the database is our compute engine. We do all our calculations in the database because databases now are very powerful. They have powerful, very expressive query language that allows you to do many calculations very quickly with large volumes of data. And so we rely very heavily on that capability. So on the right, you see a set of footprints like Brad was just showing you a minute ago. And this, I believe, is M101. And you see a big jumble of observations. And the reason is, one important point to realize here is that the way Hubble observations are done is that there are many proposals that may cover a single object in space, and they have different scientific purposes in general, and they may use different instruments, different filters, different exposure times. They may be taken with different orientations of the telescope, and so it's not what is considered to be a survey telescope. There are telescopes that are designed to do surveys, like the Sloan Digital Sky Survey, that take very well thought through exposures that tile the sky, or portions of the sky, but Hubble doesn't do that. So we're trying to add rationality to this complex mix of exposures. Okay, so what we're really trying to do is figure out a source in one source list. What does it correspond to in another source list? that may have been taken by a different instrument, a different filter, different exposure time, and so on. And the reason we want to do this is similar to what Brad was just saying, but we can get, for instance, time information because the exposures is taken at different times. So if we have information about source information about the same object in space, but taken through exposures at different times, we can get some time information about this object. If the exposures are taken at different filters for this object, we can get spectral information about the properties of the object. So the key to the whole thing is tying together these objects, like you see in the left panel, that are numerous, and seeing which ones actually correspond to each other in another image. Okay,
so a good example of that was something we talked about last week with a supernova that was lensed in one of the fields of frontier fields, and they saw it in a recent observation, and then they were able to go back, I believe it was mid-2000s, and see that had been observed earlier, and so this sort of matching of sources is actually pretty important to be able to do that, correct? If you wanted
right. That's
to
exactly
you see a supernova and you want to see, are there any other observations of this thing prior to the supernova going off or whatever it is, then you can make that connection, and that's one of the things the Hubble Source Catalog is doing, right?
That's right, exactly.
Okay,
so let's now go to the next slide. Okay, so as I mentioned, there are these diverse programs, there's complex geometry, there are different instruments, filters, exposure times, and so on. And another challenge of Hubble, as Brad pointed out, is it has a small field of view. So the reason that's a bit of a challenge is that a lot of these standard catalogs don't have many sources in a Hubble field that we can align the images by. So a big challenge of the project was to first align the images with respect to each other, so we can tell which sources and different images actually are in the same position. So they're actually the same object.
And that's usually done using something called astrometry, where you are accurately pinpointing the positions of these things, and then trying to get the orientation.
Right. That's right. So to do this for Hubble, we had to come up with a new algorithm for doing the astrometry corrections because of the special challenges of this small field of view and the many sources that could be in each exposure and the many exposures that can overlap with each other. So that is discussed a little bit in the next slide. Oh, sorry. This slide is a discussion of the contents. We'll get to the algorithm in the okay. So what we do is we take sources from different images. So you see here they're red and blue. This is a very simple looking example, and we try to shift these images relative to each other so that the sources overlap well. And our algorithm for doing it is a very mathematical one, but it's physically equivalent to tying these sources together with springs and minimizing the energy in these springs. So that's the idea. And it turns out that you can do this almost analytically, so it's very fast. You need to, of course, have the data, but it runs very quickly, and we have to do this, in some cases with thousands of overlapping exposures, and we cycle through all these exposures iteratively 50 times. So to make this at all feasible, the algorithm has to be super fast, which it is. So if we could go back one slide, I'll tell you a little bit about the properties of the catalog. So we have about 100 million sources, okay? But
that's how many are in the Hubble source catalog, 100 million?
Right now. Now, these aren't objects, these are sources, okay? So that's per...
What's the difference?
Well, you can have several source detections that become one object, right? So these are these are 100 million source detections. Okay, so if I see a source yesterday and I see it today, that's one object but two sources.
Okay.
Okay. So,
I think I understand. So the
and
source
each
based
one,
on an observation.
right.
Okay.
Exactly. And each
But
one
I still don't see the difference. But I guess we'll worry about it later.
No, the difference is that they could have different brightnesses. They could have changed. Okay. So
right.
we have data on each source. Okay. Each time it's observed, we have information about it.
Okay.
And we also have information about non-detected sources. Okay, which sounds bizarre, but we do. Okay, so we have 80 million that are detected. Okay, but we have 20 million that are not detected. So what that means is they're detected in some filters, but not others. And we keep that information in the database. If something is detected within some circle, which we call, an aperture, then that's the source, okay? But it may be detected in some filters and not others, and we keep information about the non-detected sources. So we have information about what filter it was that we couldn't detect it, when, and so on. Okay.
So a simple example might be you see a galaxy in red filter, or maybe even infrared, but you don't see it at all in, say, the UV filters.
Exactly.
You keep track of that information.
Yeah, we keep track of that, and that's useful information because it tells you something about the spectrum of the source. Okay.
So you know what you don't know. That's
right. Exactly. So, now, we don't have all the Hubble images for these instruments. We have 3 instruments in there right now, ACS, WIFPIC-2, and WIFC-3. We don't have all of them because some of the images have quality problems. There's the source lists may have problems. There may be problems with cosmic rays and so on. So we have most of them, not all of them. We're working on trying to boost that percentage, but that's basically what we have. So the whoops.
Are there ways to eventually add those up? Are there plans to be able to add that data to even broaden out what they have?
Well, I mean, there are some images we can't really do anything with, okay, because they're not that they had drifts, so things are streaked across the image. Some images that we really can't do anything with, but we are trying to expand the scope of the images we're considering by using various algorithms.
And we kind of improve our catalogs as we go. So, for example, the WIFC-3 catalogs are actually quite a bit better in quality than the WIFPIC-2 or ACS. So we're going back with those algorithms and improving those catalogs. Well, we'll never get to 100%.
Because there are just some images that you just can't improve.
It's like the ones where you left your finger over the camera lens.
Wait. Does Hubble have a finger? I have not heard about the Hubble finger.
Little known fact.
You've not heard about the Hubble finger? It's legendary. We're getting we're getting a couple of really good questions on the Q&A app. Let me get a couple in. Fubar Gorch is asking on the Q&A app, is there a way to go back from Hubble heritage photos to the original observations they were constructed from? Who wants to take that?
I can take that.
You're nodding your head, so why don't you answer that?
Or Tom could too, actually. He's working on this. We actually have a project which is going right now to tag all the public press release images with information that tells precisely what observation, precisely where the observations are on the sky, and also linking them back to the original observations in the archive, so that you can go from a press release image to archive observations, and you can go the other direction too. You can go from archival data to press release images, which is useful for astronomers. For instance, if you're giving talks, you can get the very best version of an image of some object by starting from your archival data, but then noticing it got used for press releases.
Okay.
Well, I think that's good too for the general public, is that so many people see these beautiful images and want to make their own. And
Right.
so,
Try to yeah.
yeah. I mean,
And that's
I've done
something
that
huge.
myself using the lovely tool that is Bits Liberator, and and it's a bit of a learning curve, but getting into it really allows you to use that data and really pull out the beauty that Hubble is able to observe. So not only are we getting great science out of it, but it does allow the astrophotography community to really use some hardcore data to get some really good astrophotography through.
Yeah, I might just mention.
I was going to mention that there's a way that you can actually search for the press releases through the archive, but there's also a facility where all the observatories have gone together and to index the press releases they have, and that's called AstroPix. And you can go to AstroPix and say, show me galaxies, or show me stars, or show me planets, or whatever. And then the ones that are in Hubble, that comes back to our archive, and then it refers to the science observation.
Very good.
Yeah,
Go ahead.
I might also point out that when I showed the interactive display from the Hubble Legacy Archive, at the top you might have noticed kind of a red and a green and a blue little tag there with a filter name there. And so people can get in there and make their own color image and adjust the color image and change what filter observations go into it. So they can make their own images without having to kind of get into Bits Liberator and things like that.
Right.
Okay, Judy Schmidt has a great question on Q&A. I'm sorry, but the timestamp got messed up on your question, Judy, because I clicked on it and then I couldn't get to it. So she's got a really good question. So for something like the Ultra Deep Field, does the source catalog make it possible to determine the distance to each galaxy? I've been wondering how a 3D fly-through animations are created and if the catalog is used. That's something Frank did with the Hubble Deep Field. So is there things like redshift information in the Hubble source catalog?
Not yet, but there are people thinking about doing that. That's a possible.
Can one use the catalog to get the information based on the filter? Like, what's that called?
Photometric.
Right. Is that photometric redshift?
Photometric redshift.
Yeah,
Okay.
either that or Photo Z.
Yeah.
Photo Z, right. That's where if it's bright in certain filters,
right,
and you take it and in other filters it's subsequently bright in whatever way it is, you can infer or calculate the redshift from it, correct?
Right.
Now that's not as accurate as looking at the actual redshift from a spectrum, but it is one way in which people do it. Good question, Judy.
Right. I do have a great comment from Twitter, so I'm actually going to share this one up here. And I hope I pronounce it right because from Holland. But so Benny Holliverda.
Oh, hi Benny.
Benny.
Oh, it's Benny.
Hey Benny, we know.
And when we're talking about taking the month's worth and putting under 2 minutes, like no kidding, with HLA you can redo the first few months of my PhD in a matter of minutes. But I think that goes to show that this is amazing, and what we're able to do now with technology, we're really able to advance the amount of work that can be done now that we're able to get these archives together and have them easily accessible, and that they're tagged correctly would also be very helpful for many other archives that are out there. So grad students and postdocs and those that are looking to put out even more science, it's more easily accessible for everyone to put out even more science.
Right. Well, one way to think about this is that we're entering a new era in astronomy, which is big data. Big data you've heard about in more commercial terms with people tracking your cookies on your web browser and that sort of thing. But big data is beginning to hit astronomy. There are large catalogs like this, and in the future, it should be possible for people to do a lot of their research using products like this that save a great deal of time. So it may be possible to do things that previously would not be undertaken because of the amount of effort that would have been required, as Brad described. So it may introduce a qualitative shift, not only in the nature of the science, but also in the kinds of skills and the workings that an astronomer would do to do a scientific project.
Can I suggest we
Right.
go ahead to Rick's demo next?
Well, we really did. Yeah, I need to move this along. Poor old Tom
Okay.
has been sitting here, and
Okay.
I haven't even gotten to him yet. So yes, let's go ahead.
Okay.
Go ahead, Rick.
Okay. Well, I'm going to do a quick demo using the MAST portal, which is also what Tom is talking about. If you go to mast.stsci.edu, this is big enough to read. You have various things you can search now. One of the things you can search is the Hubble Source Catalog. It's this third thing on the list. And I have a script of a particular object. You can search for anything that you want, but I'm going to put in a particular position in the sky because I know it's of interest.
And can you explain the difference between MAST and HLA?
HLA is actually part of MAST. MAST is, well, formerly it was the Multi-Mission Archive at Space Telescope. Now it's the Mikulski Archive for Space Telescopes, named after our wonderful Senator Barbara Mikulski. MAST is a multi-mission archive. It includes not just Hubble data, but includes data from a lot of other missions like GALEX, ultraviolet satellite that did a sky survey, Kepler, the mission that observed a lot of transiting planets. And
That's right. A lot of people don't know we archive Kepler, all the Kepler data. That's right.
So we're the archive. Basically, we're NASA's archive center for data that covers a wide wavelength range going from the far ultraviolet into the infrared. We will have the James Webb Space Telescope here in a couple of years, if all goes well with the launch. So MAST has data from about 20 different missions, one of which is Hubble. Hubble is the one that attracts the most attention because it's the most fabulous, unique data. But we have lots of other data, which is valuable too.
Okay, so
and the cool thing about the MAST portal is you can search all those missions with the MAST portal. Tom will talk about that. In fact, you can go even beyond data that MAST holds here at Space Telescope in Baltimore. You can search missions, data from missions around the world.
Okay, great, thank you. So now you've got a search in here with some coordinates, and this R equals 0.5 m. What is that?
That's a radius. So that's a
what?
search radius. That's just put in to restrict the number of objects. And in fact, this plot over here on the side. Do we have a charger?
I have one.
Okay, you might go get that because it's warning me.
Here's one right here.
Oh, yeah.
Okay, it's warning me that the
Hopefully
battery's
it's the
going
right.
to
Yeah,
die
that's for
soon.
mine. Yep. Okay.
Anyway, so these are all the observations that showed up. If I zoom in, you can see that these are individual sources. These are objects in the Hubble Source Catalog. The image in the back here is an image from the digitized sky survey. You can see it's got stars and galaxies. It's not particularly useful for this particular observation because there are so many Hubble objects packed so close together that there's not much you can see there.
So in that right ascension and declination and at that radius, there are all those objects.
All those objects. We found 1,603 objects within just a half arc minute search radius of the search position.
Okay.
There's a way to get the Hubble image itself to appear. If I click on, there was a little icon which gets details of objects. This now is showing for one object all the Hubble measurements that exist in the Hubble Source Catalog. If I scroll down this table, there are all these different observations. Each one of these images over at the side is a little snapshot cut out from the middle of the Hubble image. This went right to Go ahead.
Where can you find out what it is? Like, is it a star, a galaxy, or how do you? Is there something that tells you that?
If you go back to the observations, the easiest way to get an idea what it is, at least, is to look at some of these parameters. I'm not going to talk in detail about them, but there are things that give like sizes of objects. There's something called a concentration index, which is over here.
Well, the flags.
The concentration, the flags also tell whether it's extended. The concentration index. Around 1.
So it's embedded in there somewhere.
Yeah, it's embedded in there, but
Okay.
it's not there in a super easy to tell way. Actually, if you look across here, there are other things like magnitudes of in different filters and so on. If you do searches at different places in the sky, you'll see potentially very different lists of observations. This one is actually fairly simple. There are lots of observations, but only 2 different filters. There's a blue filter and an infrared filter. Some other place you might see observations in 20 or 30 different filters for objects. So it depends, because of this spotty coverage that Brad talked about, it depends on where you are in the sky. So if I go back over to here with these observations, there's a little icon here which says toggle overlay image. I click on that, and if I pause for a minute.
Hopefully not a minute.
Not a minute. It does a query and it returns a preview version of the Hubble data. Ordinarily pretty quickly, but there we are.
Well, probably everybody watching is also right now catalog.
Actually, if you zoom out, you'll see that the digitized sky survey is still there, but here then is the Hubble instrument field of view. And if you zoom in enough, then you can see that now these objects fall, these Hubble Source Catalog objects fall on objects that are visible in the image. So there's the Hubble data.
I'm really impressed that you can do all this in real time. I mean, that's pretty amazing.
That is amazing.
Thank you, Tom.
Yeah. So can I? I don't want to rush you. I really don't. But we're running out of time, and Tom still hasn't shown us his stuff. Do you have anything more for us, Rick?
Oh, well, I've got lots more. But
no, 2 or 3 minutes.
Can I? A couple of minutes. This is actually one of the coolest stuff. Okay, so watch this. Ready? You thought that was cool. This is all stuff that Tom wrote, by the way. So we'll give Tom credit for. There are a lot of things that you can do from this table. One of the things that you can do is you can do plots. This brings up a plot of things that are in the catalog. Right now, it's plotting two variables that are not particularly interesting: the match ID and the distance from the search. That's what it comes from.
What's the distance? Distance in.
That's the distance from the search position that I.
Oh, okay. So that's not what Judy was talking about. Just clarifying.
Yeah.
Right.
But if I instead, I can pick any of the variables from this table. So I'm going to pick. Oops, come on. Oh, I'm not used to this scroll direction here.
That's one of the filters.
Yeah.
Okay.
So now what I'm looking at is a plot of the magnitude in the 475W filter. That's kind of a bluish, kind of blue-green filter in ACS. And then on the y-axis, I'm plotting basically a measure of the variability in that magnitude. So there are cases. In fact, I can improve this if I go, back to this plot. Hang on a second while I don't really want to do that now. The reason there are some things down here that don't have any variance is because I included objects that only have one measurement, so those are not particularly interesting. Anyway, if you look at these objects that appear right here, there's a little spike of objects. These are objects which are actually highly variable. They've been observed many times, and in all the different measurements, they turn out to be quite different in brightness. And you can find out the properties of individual ones. Like I'll just pick one here. If I click on this, actually, if I went back over to here and zoomed out, I won't spend too much time on this, but it's possible to find it highlighted the one object. There it is down in the corner of this image. It shows up as a different color. It's also shown up here highlighted. This is that most variable object. Again, I can find all the individual measurements for that object. And now I can do one more plot and get a plot versus time. So I'll pick the start time for the x-axis and the magnitude.
Yeah,
I can get my
down.
scroll bar to work. There we go. Mag-aperture, update series. And now we have a plot versus time of the brightness of that object. This is a little bit confusing because there are multiple filters which are being plotted here simultaneously. And I'll just cut short the demo, but it's possible to then filter out just the F475 filter. And what you see is that this object has a light curve where it gets, actually I can reverse this axis to make it clearer. That now the bright objects at the top are at the top. I got that right? No, I went the other way. The bright objects are at the bottom. Now the bright objects are at the top, yes. Ooh, that's interesting. Didn't change the axes. That's a bug, Tom. Anyway,
No, you're trying to change the x-axis.
oh, I'm changing the x-axis.
You want
You're
to
right.
change the
Yeah. So that was not a bug.
So it's just
That's
what we get.
Driver.
Astronomers need to read the instructions.
No, we're not going to do that.
So these objects,
Carol's still standing her ground.
this thing sort of changes in brightness with time. It gets fainter and fainter, and then it jumps in brightness, and it gets fainter and fainter again. That's characteristic of, these are Cepheids, is that what they are?
Yeah, most of these are Cepheid variables. So you've just found 50 Cepheid variables in a couple minutes.
Yeah, so there's a whole bunch of other stuff you can do here. You can do things like you can compute colors from from magnitudes in this catalog. I could plot a color magnitude diagram. You can look at the variable objects and see, oh, they're at the right place in the color magnitude diagram. They have similar colors and similar magnitudes. They're in the Cepheid instability strip. And you can do all these calculations directly in the browser. I never had to download any data to do this. So there's a lot of science that I can do right from this interface and from this data, never having to actually get anything onto my desktop. So.
Okay, that's another important point. You don't have to download all this stuff. It's all done locally on the servers at the Institute. So, very nice. Anything else, Rick?
Nope.
Okay, Tom Donaldson. It's fine. We finally get to you. Your colleagues left you 9 minutes.
All right. Go,
well,
Tom.
that's all right. Hubble Source Catalog is a major focus of what we've been doing, so this stuff is terrific. Okay, so I'm also going to show the MAST Discovery Portal. I was sort of playing along to begin with when Brad did a search of the Small Magellanic Cloud. So Rick mentioned that there were multiple things you can search for in this interface. One is you can search all the observations that the MAST archive has. You can search the Hubble Source Catalog, as Rick mentioned, and you can also search something called the Virtual Observatory, which is everything outside of MAST, essentially. There's a consortium of data providers around the world that offer their data in a protocol that that allows us to discover that data. So just to summarize, before I did a Small Magellanic Cloud search of all MAST observations. And over here in the sky display, we can see their footprints. And again, this is essentially the aperture that took a picture on the sky. Now, there's a lot of stuff over here. There's over 16,000 observations that MAST has of the Small Magellanic Cloud. But we can filter here by mission. You can see there's a lot of HST. Galax, if I filter just for Galax, we can see that they're the ones with these large circular apertures. That aperture is actually over a degree across.
Oh, wow.
So if I zoom in here a little bit, you can see the Small Magellanic Cloud sort of hiding here amongst all these Galax observations. If I get rid of those and just filter on Hubble, okay, so here's all the observations again. If I just filter on Hubble, you can see that the Hubble apertures are much, much smaller than the Galax apertures. And if I start to zoom in here, I can see an awful lot of these things all over the Small Magellanic Cloud. Brad, I think, was looking at the WIF-C3.
Wide Field Camera 3.
So if I sort all the instruments I have alphabetically, it makes it easier to find those particular ones. They have some infrared and some ultraviolet observations. Notice there's a cluster of them over here out on the edge of the observation, and I think this was the object Brad was focusing on as well. It's 47 Tuc. So you can see a cluster of Wide Field Camera 3 observations there in a variety of arrangements. We
might say that's a foreground object in our galaxy that's actually not associated with the Small Magellanic Cloud. It's just sort of in the way.
Yeah, it's a globular cluster.
Right. But it's a particularly pretty object.
Oh, it is.
Okay, so Brad had searched the Hubble Source Catalog there. I'll go ahead and do the same thing, but then I'll get to the Virtual Observatory. So this is just 47 Tuc. I'll limit my search to not the whole Small Magellanic Cloud. I actually have no idea how many Hubble Source Catalog objects are in the entire Small Magellanic Cloud. It's probably more than I want to deal with here. And in fact, I've hit my search limit here of 10,000 objects just searching 47 Tuc. But you'll see that where the digitized sky survey background is essentially white here in the middle, it's just washed out with so many objects. Hubble found 10,000 objects here in the middle. And so if I do Brad's trick of going to see what some of these images look like and then overlaying the image, and as Rick said, it should be almost instantaneous. The thing is, the Hubble image is a very high resolution image, so we're actually downloading a JPEG form of that entire.
And it's creating this right now as we speak, right?
Yes, that's right. And there we go. So you can see the difference here between the digitized sky survey side and the Hubble side.
Yeah, look at that. Resolution.
And we can actually see that these are actually objects that Hubble can see, and the telescope for the.
And that is a plus for having such a small field of view. That's what small field of view is, folks.
And spatial resolution. Okay, now I'm going to search the virtual observatory at this same location. Now, what happens here? I'm going to get data fairly quickly because I performed this search recently within the last half hour. So it's actually
it caches queries then. That's good.
It caches queries. So, and if someone else runs the same query right now, they'll get the cached version, and it won't take any time.
Oh, that's great.
This search, when I did it the first time, took 2 or 3 minutes to complete, but I started to get results within 10 seconds or so, and then I was able to refresh my display with a button that appears up here as new results come in. But so what am I looking at here? Nothing is drawn on the sky for these results yet, but what I'm looking at is a list of data resources from archives around the world that say through the virtual observatory that they have some data at this place, and they have data that are catalog data, they have image data, and they have spectral data. And again, you can use this filtering mechanism to locate those. You remember some of the catalogs we saw at the top of the interactive display that Brad was showing? They had, for example, the 2MASS catalog. Well, we have 2MASS catalog results showing up here, and if we click on this load button, we can then load these 2MASS objects into the interface, and I believe 2MASS is probably going to have identified a lot of objects in this region as well. Yeah, so 2MASS has over 10,000 objects here as well. And when we see those in the sky, in just a second here, the more objects I load, the slower it gets. There we go. Okay. So when I see these in the sky, and I have to zoom out now to start to notice these. See, these 2MASS objects, if you can see, are showing up in green, and they're much more widely spaced than the Hubble Source Catalog objects. Again, because it wasn't such a high resolution observation. You can see that many of the objects that 2MASS has identified are apparent in this Hubble image. So any data, you notice every one of my searches creates a new tab here, and there's various things I can do. I could export this data to a file. I can broadcast it, and I'm going to finish up real quick because I know we're out of time. But I can broadcast this, and I'll approve this. And if I am running other virtual observatory enabled tools like Aladdin, or if people use DS9, then these tools will automatically read this data. You can see Aladdin and DS9 are now loading this data. And again, there's over 10,000 objects, so it's not instantaneous for them to load it. But it's a shortcut way of, once you want to move beyond the capabilities of this tool, you can use those other tools. And I'll just point out that very quickly, if we had searched or filtered our virtual observatory results by image, we can see there's a number of different images. Spitzer and Chandra all have images here. If I load a list of Spitzer images, I'm going to have to zoom way out because their apertures are much bigger than Hubble's. And it looks like I'm going to be drawing these in some sort of pink color.
Okay. Okay.
Now, recall that I have tens of thousands of objects being drawn here, so it takes it a minute. But then I could select graphically these images and download them in a similar way, or broadcast them to to my other tools. And I'll finish there.
Okay, well, thank you, Tom, very much. This is, you know, Carol, we should, this reminds me, as they were talking, we should probably have a hangout sometime on virtual observatories, and that include Hubble, but, you know, what you know, some of the other ways in which astronomers are interacting with their data. That might be an interesting hangout, too. It just occurred to me.
Yes,
All right.
and I mean, the way I say it is that what we're trying to do is create, through these environments, and it requires a lot of technical cooperation between the archives, is that astronomers, as you heard Bene say, you know, they want to say, tell me about this object, everything that the observatories know about it. And it used to be just the data. Now we're getting data analysis with the source catalogs. And so one can work a lot faster and pose new questions about these objects that we couldn't before, that would take a long time to answer. So the fact that through one mechanism and interface, astronomers can get their hands on all of this information means that they can get a really good picture of the objects that they want to investigate.
Yeah, I remember when I first heard about virtual observatories, I was very skeptical, but actually it's coming into its own now. I know we're over, folks, but Charles Bell has a really great question I just want to ask our guests, because he actually uses some of this stuff. Is there a way to get stellar proper motions from all the thousands of overlapping exposures and get that into the catalog? Would it be better than the UCAC4 source catalogs that are currently used for astrometry? And that's what he says he currently uses. I'm not familiar with that catalog, but
so let's see. So it is possible to get proper motions. We don't have proper motions computed for objects, but actually you can. We didn't talk about, there are other interfaces for accessing the catalog, and one of them is through the system called CAST jobs, which allows you to query the
from Sloan.
So you use CAST jobs, you can query the Hubble source catalog, get all the individual measurements of objects that went into that, and then you can look for systematic shifts in those positions with time. Whether it would be more accurate than UCAC, it's not clear at this point. We get very accurate relative measurements between the Hubble positions. So you should be able to get very accurate relative astrometry over epochs. The absolute astrometry, we're still relying on catalogs that exist on the sky. So we rely on Pan-STARRS, which is tied to 2MASS. We rely on Sloan and 2MASS itself when either one of those is available. And there are some places in the sky where we don't have any reference catalogs to use, really, so the positions might be not so good. So the absolute astrometry may not be great, but the relative astrometry should be very good between epochs. I mean, Steve has done some calculations and finds that the typical error in the astrometry between epochs is about 6 milliarc seconds.
Yeah, and to give an idea of how big a milliarc second is, I just worked this out last night. A person standing on the moon, as seen from the Earth, is about 1 milliarc second.
Okay. Oh, I do that all the time. Thank you,
What, stand on the moon?
Yeah. So that data is all there. It's not organized right now in a way that makes it super easy to do, but it's all public, and you can go in there and you can grab that data and you can do your own calculations of proper motion.
Yeah, so give it a try. I did not know you
Really
could query the Hubble source catalog from CAST jobs. That's great.
Yep.
All right, folks, I want to thank everybody. This has been a great hangout. Thank you all for taking the time out to show us all of this stuff. Brad, Scott, and Rick, as well as Tom Donaldson, thank you all very much for taking time out. We really enjoyed learning about it. Next week, we are going to be talking about dark matter, because it turns out NASA's Hubble Space Telescope and Chandra, the observations have found that dark matter interacts with itself even less than previously thought. So we're going to talk about that next week. We hope to see you there. On behalf of Carol and Scott, I want to thank everybody for watching, and see you next week. And as always, keep looking up. Hello, everybody, and welcome to this week's Hubble Hangout. My name is Tony Darnell. I work at the Space Telescope Science Institute, and this week we've got another great hangout plan for you. If you are interested in Hubble data or in getting some yourself, then this is the hangout for you, because we're going to be talking about a new and revamped Hubble source catalog that you will be able to peruse and query and get Hubble data yourself. So that's in just a moment. I'll introduce our guests that will help us understand how to go about getting this stuff. But in the meantime, before we get started, a couple announcements. Hubble Mania still going on. The link is down in the description box. Go vote. Vote early and vote often. Actually, you can only vote once. But the latest round 3, has started yesterday. And my favorite image, the Hubble Deep Field, died long ago. But now there's still a few that are still out there. The Pillars of Creation is still there.
That makes me so sad. You have no idea how sad.
Oh, believe me, I really pushed for it too.
Yeah.
And but you know, the Sombrero Galaxy is still alive, which is
Yay! That's yes, that's the observation. I rule.
That's the one I'm rooting for now. So we'll see how it goes. Also, the voting is still going on. The crowdsource voting is still going on for the Ode to Hubble video contest. They had a lot of great submissions. So please go. The link to that is also in the description box. Go to their website, and you need a Facebook account because they base it on the number of likes. But you can like as many videos as you actually do like. So please go and vote for that and participate there. We just got back from South by Southwest, or at least many people are getting back from South by Southwest, where they had a big exhibit and things going on at the Interactive, as well as the Gaming Expo. So if you were in Austin, I hope you had a chance to go down there and check that out. So before we get started with today's hangout, let Scott know. let Scott tell you how to leave us questions and comments.
Let me know. I don't know what I'm doing. Let me know, Tony. But
my all-time favorite was the one in Spanish, Oblandos. So of course, the H is silent in that because it's Spanish. So hola, Oblandos.
Oblandos. I like it.
Oblandos.
But we can thank Telehubbies to Heather, who's from Johnson Space Flight Center, and thank you, Heather, so much for that. You were amazing.
Telehubbies was hilarious. Yeah. So if you've got any more, keep them coming, because that was really. We should have a contest. We talked about that last week. Okay, so the Hubble source catalog. Carol. I got to introduce you. Hi, Carol. You're muted. That's why. When you mute, you just disappear to me. So.
Oh.
Hey, Carol.
I am dead to him.
You will never be dead to me, Carol.
Talk to the head.
Thank you, Scott.
You're always.
You are dead to me.
No matter what.
I
disown you. Dr. Carol Christian is the Hubble Outreach Project Scientist. She joins us every week. Hi, Carol.
Hi, your funding has just been cut.
Ooh, note to self. Be super nice to Carol. Okay. So the Hubble source catalog it's been around for a long time, and it keeps getting updated. And as you all know, Hubble is celebrating its 25th year collecting data, and eventually everything Hubble looks like makes its way into this archive. And if you have ever been wondered how to get at this and how to use this data, we'll show you that today. And it's gotten a nice revamping by the Hubble Source Catalog team. So joining me is our various members of the group. It's a bigger team than here, but these are the ones that are going to show us how to use it. We have Dr. Brad Whitmore. He's an astronomer here at the Space Telescope Science Institute. Also, Steve Lubo. He's also an astronomer. And I see Rick has joined. Hi, Rick. Rick White, also a member of the Hubble.
Okay, Small Magellanic Cloud.
Okay.
So it's a dwarf galaxy in the southern hemisphere. It's quite a bit closer than even the Andromeda Galaxy, but since it's a dwarf, it's not as popular. Anyway, here it is, and you can see, here's the problem. We have 11,000 observations with Hubble of the Small Magellanic Cloud.
Woohoo!
Is that it?
This is going to take a while.
I expected more.
Oh, yeah? Okay. Sorry. Okay, so here we are. We can go to footprints. with the spinning ball, which hopefully is going to go away in a moment or two. But anyway, on the right there, what you're seeing is a picture of the small Magellanic Clouds, and all these little dots here are individual footprints. And here's kind of a compilation. With the advanced camera for surveys, there's been 2,500. Wide field planetary camera 2, over 2,000. The newest camera, wide field camera 3, 700, etc. So if I was going to work on this myself, I would be downloading data from this for days until it essentially got it all, and then I'd have to figure out which data is actually useful for me.
Could you explain to me what you mean by footprint? So if someone's logging on this for the first time, they might not understand what you mean by footprint. What exactly is that corresponding to?
Right. So okay, that's the field of view. For example, the advanced camera for surveys, when it takes an image and that little footprint from it, that's the part of the sky that it sees. So it's a very small, what we call kind of pencil beam of the sky. So that's probably a lot of people don't realize that the images from Hubble are a very small part. I don't know how many it would be. Maybe someone can calculate for me. But if someone wanted to look at the moon, it would be hundreds across. It would take you forever. So we only do very small parts. Okay, so there are all the observations. Let's go ahead and limit it a little bit. Instead of doing all the instruments, let's just go ahead and look at the wide field camera 3 observations. So now we're down to 700. And so let's look at a few.
For those of you who are newly joining us, there are many, many different ways for you to get in touch with us. The easiest and most effective way is to use the Q&A app. So you're watching us over on YouTube right now or embedded somewhere on our website with the YouTube. You'll be on the very bottom left. It says that we're engaging with you. You're allowed to ask us questions live on air. So it will populate to our right, and we'll be able to click them and answer them live. So if you have questions for any of us or any comments that you'd like to make about today's topic, please use the Q&A app, and we'll be able to not only select them, but it will put a timestamp to whenever we answer your question. Another thing as well is we are over on Facebook. So, excuse me, well, we are on Facebook, but I'll be checking the Hubble Hangout hashtag over on Twitter. So if you haven't already, follow us on Twitter at Hubble Telescope, and I'll be monitoring that hashtag too and replying back. And we'd love to see what your favorite images have come out of the Legacy Archive as well, if you've done some in the past, like Judy Schmidt. And I know you have.
Know who you are, Judy.
I know you have, Judy. And I know you're probably watching. So please share with us your favorite images that have come out of the archive and what you've learned from previous sessions with the Legacy Archive and what you're learning today.
And did you tell them about YouTube? You can comment on YouTube as well?
No, I guess.
Yeah.
If you want to comment on YouTube,
we're also monitoring those as well.
We will monitor them. I am also moderating them too. So please keep those.
It's come to that,
comments.
folks. It's come to that. We have to monitor.
It's come to that, but it's YouTube, so that's okay.
Yeah, the wild west of the internet. You know, it's funny. I had a lot of fun last week on Twitter looking at the Hubble Hangout hashtag tweets, where there was a little thing going on where a lot of people were coming up with new names. In addition to Hubblers, we had one of my favorites was Hubbies, which then led to Telehubbies, which
thank you, Heather.
And there was that Force Catalog team, and also from a remote location high in the Arctic. I don't know where he really is, but is Tom Donaldson. He's one of the programmers that I have a feeling knows this thing inside and out more than.
Or Fred. I hear he also goes by Fred.
That's true. He does. I think that's his alter ego there. So anyway, so let's go ahead and get started. Brad, why don't you give us first of all an overview of the catalog itself and what it is you're going to be showing us?
Okay, well, I think as most of our users probably know, Hubble's been in orbit now 25 years, and so we've got a lot of observations. We've got over 1 million observations, and for an astronomer, that poses a problem. I mean, it's hard to find sometimes exactly what observations you need. In many cases, there's so many observations, it takes a long time to work on. And so that's what the Hubble Source Catalog is all designed for. Now, at the basis of that is actually the Hubble Legacy Archive, which is where we'll start right here. So if you just do a Google search on the Hubble Legacy Archive, why don't you go ahead and switch screens there. There we go. Here we go. It's the second one. Welcome to Hubble Legacy Archive.
Wait a minute. What's the first one? Human leak? Oh, okay.
Okay, there you go.
Well,
tell me
HLA.
all about this, Tony. Yeah.
So, to be fair, that's HLA, which could mean anything, but
Yes, I
Hubble
know.
Legacy Archive.
But it does show up quite a bit.
Yeah.
So the Hubble Legacy Archive has been out since, I guess, 2008, and the Hubble Source Catalog is kind of a new compilation of all the source lists that get made. And so I'll kind of show you a little bit of it here, and then Steve will go in a little more detail. Let's skip the instructions, go right into the site.
That's
we don't want to read the manual.
Because that's what astronomers do. We don't. They spend all this time writing the instructions, and it's like, forget it. If you we're just going to go straight in there. Yeah,
change
really.
log. Who needs a change log? Let's go.
Exactly.
Okay, and so I'm going to kind of take this from an astronomer's standpoint, which is I've got some object I'm interested in. So I'm going to go to Small Magellanic Clouds, SMC.
Well, you're into those acronyms.